All right, hey, students have been asking for more practice on accuracy, precision, percent error, and quantifying precision or expressing the uncertainty in measurements. So go ahead, pause the video if you haven't tried this and read through this problem. You're a chemist or a chemist at a pharmaceutical company is doing some quality control on these dispensers. We've got 3 dispensers. Let's see where my pen is. Dispenser 1, dispenser 2, dispenser 3, and what we're trying to do is dispense 10 ounces or 298 mils of cough syrup into these bottles. So the results are tabulated below here, and the question has several parts here. Part A is asking us to identify the most and least accurate dispensers. So accuracy is you're comparing your measurements, your measure, right, to the true value. And in this case, we're trying to get 10 ounces or 296 milliliters. So let's compare the accuracies of these. So 290, which one are these, which measurements, set of measurements are closest? This is going to be the most accurate, dispenser number 3, because they're all 0.1, looks like, away from the true value, which is 290, 296. So this is your most accurate, and which one is farthest away from 296? Looks like dispenser A is least accurate. All right, so you could have, if you don't see this right away, this is most accurate. All right, you can get the you can punch in these numbers and subtract it from 296, and on average, dispenser A, not even on average, every one of them is farther apart than the other 2 dispensers. Now, let's do precision. Most and least precise. Precision refers to the reproducibility of the measurements to each other. So how likely are you able to get repeated measurements? So this comes with more finely incremented or finely tuned equipment. So this is not comparing to 296, but rather comparing the measurements to each other. So if you compare this set of numbers, looks like they're all within, the lowest number here is 0.9 and the highest is 0.4. So this is like the range here is 0.4. I'm sorry, that's 0.3. So the range is, they're off by 0.4. All right, now over here, oh, this one's least precise, looks like. Least precise. All right, because they're kind of all over the place. All right, I don't even need to do any math for that. That's the least precise. And this one here is all, that's the lowest number, that's the highest number. So this one's off by 0.2. So this is your most precise, because all the measurements are fairly, or are the closest to each other, most precise. All right, so let me look back here and make sure this is good. Oh, no, hold on. This is, I'm sorry. All right, that's 0.3 is the lowest, and this is 0.4 is the highest. Yeah. The range here is, right, 7 plus 1 is 8, 0.8. Right, is the difference between the highest and the lowest. And let me just do this one here. Yeah, this one's definitely least precise. B is least precise. Right, so that's how you do that. And then let's do calculate the average error, percent error for dispenser. All right, dispenser number 2, average percent error. So whether you do this individually and then get the average, which would be a lot more work, I'm just going to get the average first and get the percent error one time. So I'm going to get the mean here. I'm going to add them up. So 298. Oh, what? My calculator's going crazy. All right, here we go. 298.3. What? Oh, I keep pressing the wrong button. Sorry. 298.3. I have a new calculator. Plus 294.2 plus 296 plus 297.8 plus 293.9 equals 1480.2 divided by, there are 5 trials. So the average, dispenser 2, got some more space here. All right, so we're going to use green for part C. All right, so the average is 296.04 because they're asking us for the average. All right, there's the measurement. We're going to subtract that from the accepted value is 296 exactly. Right? Let me just go back, make sure I want to do this over again. 296 right there. All right, and put that over the accepted value is 296 times 100. All right, 296 divided by 296 times 100. All right, so the percent error is 0.0. Let's get proper sig figs here. One significant figure, really? Okay. So that's one sig fig is going to be answered. Now I got a 3, 5, 1, 3, and all that, but we can't have all of that. So there is our percent error. All right, last one. What have I not used? Red. Expressive precision. We are not going to use the standard deviation. You can look that up if you want to do that. We're just going to use a simplified method where we take the mean, which we already did, so we don't have to do that again. We're going to express the precision in terms of the mean and plus or minus the range from not the largest to the smallest measurement, but the farthest measurement from the mean. So we already have the mean. This is 296.04. We just did that earlier. So it's going to be 296.04. All right, plus or minus. Let's see which number is the biggest and smallest, and see which one of them is farther away from the mean. All right, dispenser 2, the biggest number is 298, looks like. That's the biggest one. Right? All right, so let's do it. 298.3. Lost my cursor. All right, 298. What did I say? 298.3. Okay. 296.04 minus 298.3. All right, and so that's going to give us a plus or minus 2.26 milliliters. And let's find the smallest number. This one looks like the smallest number, 293.9. All right, so I'm going to do 293.9 minus the mean. Doesn't matter the order because we're doing plus or minus anyway. 296.04, and I get plus or minus 2.14 milliliters. All right, so I'm going to need to use the larger range so it encapsulates all the experimental measurements. All right, so this is going to be the answer for expressing the precision. Right? So what we're saying is if we did this 5 times, if we were to do it 6 times or 7 times, and that means you're likely to get, using dispenser number 2, you're likely to get a value 296.04 plus or minus 2.06. Now this is not proper sig figs, so we need to fix this. This is all right, let me rewrite this with proper sig figs. All right, hold on. Proper sig. All right, they originally it had precision to the tenths, so we're just going to keep that. Hope that makes sense. All right, so not our final answer. Definitely can't have it to the hundreds. 296.0 plus or minus 2.3 milliliters. All right, that's our final answer. All right, that's good.